Start, ma'am.
Yes, sir. ओम एकदंताय विद्महे वक्रतुंडाय धीमहि तन्नो दन्ति प्रचोदयात्. A very good morning to everyone. It's with tremendous pleasure I, Jyoti, Assistant Professor, Department of EC, NCET, welcomes
Hey, share, muted. Ask her to unmute.
Oh, Jyoti, ma'am. Hello.
Hello.
Yes,
Hello,
ma'am.
sir.
Start.
Yes.
Continue.
It's with tremendous pleasure I, Jyoti, Assistant Professor, Department of EC, NCET, cordially welcome you all to this AICT-sponsored 6-day short-term training program on applications of NI LabVIEW Phase 3 from 21st to 27th April 2021, which will be held virtually, organized by the Department of EC, NCET. On behalf of NCET management and the Department of EC, I'm honored to welcome Principal Dr. Jitendranath Mangara, Keynote Speaker Professor K. Jairaman, dignitaries, teaching and non-teaching fraternity, and all the participants across the country to this STTP Phase 3 inaugural session. Prayer should not be regarded as a duty which must be performed, but rather as a privilege to be enjoyed, a rare delight that is always revealing some new beauty. With this wonderful saying, I now call upon Apurva, 8th semester student NCET, for the soulful invocation. Over to you, Apurva.
विघ्नेश्वरा ईश्वरपुत्रा लंबोदरा करुणाकरा विघ्नेश्वरा ईश्वरपुत्रा लंबोदरा करुणाकरा अग्रपूजिता महिमान्विता अग्रपूजिता महिमान्विता परम पावना ओम गजानना परम पावना ओम गजानना ओम गजानना ओम गजानना ओम गजानना ओम गजानना. Thank you.
Thank you, Apurva, for the blissful appeal to the Almighty. Thank you again for joining us. A small cheer and the great welcome makes everything merry. On that tiny little note, I take immense pleasure and honor to welcome Dr. Jitendranath Mongara, Principal NCET, as well as a patron and the program chair of this STTP, for being the pillar of the strength and support you throughout. We welcome you, sir.
Thank you.
I'm gratified to welcome keynote speaker Professor K. Jairaman, Competency Developer, Bengaluru, for accepting to grace this day with his presence and also for being an integral part of this STTP from the day Phase 1 and 2 and now to Phase 3. We welcome you, sir.
Thank you so much, Jyoti Madam.
I'm elated to welcome Dr. Nagesh K.N., Professor and HOD, Department of ECE and CET, as well as a convener and coordinator of this STTP for his stewardship, vision, and commitment towards the work. We welcome you, sir.
Thank you, madam.
I'm glad to welcome Dr. Kumar K. Dean R&D NCET, coordinator of NI LabVIEW Academy. In his noble initiative, support and the guidance, NCET has MOU with NI LabVIEW Academy. We wholeheartedly welcome you, sir. I'm delighted to welcome Dr. S. Mohan Kumar, Dean Quality Assurance, for his unstinted support and encouragement. I would like to extend my warm welcome to Dr. H. Venkatesh Kumar and Dr. Basuraj GM, Professor, Department of ECE, as well as the session in charge of STTP for their constant support and guidance. We welcome you, sir.
Thank you, madam.
I extend my warm welcome to Dr. Rohit S., Associate Professor, Department of ECE, LCET, as well as the co-coordinator of the STTP for his valuable contribution towards all three phases of the STTP. We welcome you, sir.
Thank you, ma'am.
I extend my heartfelt welcome to all the department HODs for their enormous and continuous support. I extend my warmest welcome to organizing committee, teaching and non-teaching staff of ECE for your cooperation in making the STTP phase 1 and 2 a resounding success, and looking forward and hoping the same success in the phase 3. Last but not the least, I welcome all the participants across the country who is connected virtually with us for their patience and cooperation. I cordially welcome you all. May I now request Dr. Jitendranath Mungara, Principal NCET, as well as a patron and the program chair of the STTP to address the August gathering. Over to you, sir.
Yeah, thank you, ma'am. Thank you very much. And I hope that I'm audible to everyone.
Yes, sir.
Yes, sir.
Yeah, thank you. Good morning, one and all. Respected faculty, deans, and participants, and today the respected today's speaker, Jairaman Aya. And it's really great pleasure and great privilege for me to be here on this AICT sponsored FDP program, third phase, which is going on right now. We have successfully completed 2 phases with the efforts of the ECE department. They have done excellent job in this regard and appreciated for that. And they are going to complete third phase also very successfully. And at each and every stage, 150, 120, and 110 or 100 plus this time. This many participants got advantage with this particular FDP program. It's really encouraging to the department and to the NCET too. And on behalf of NCET administration and NGI management, that is our management, we welcome you all once again to this FDP program. We are sincerely thankful to all the people, those who participated and participating right now, for encouraging us to do such type of technical faculty development programs. And of course, it is sponsored by the AICTE, and we are always thankful to the AICTE and VTU. So it is a continuous process for any engineering college. Of course, our department, ECE department, is doing very good and awesome job. Every year, almost, they are conducting this type of the seminars. It's really encouraging, and definitely I need to appreciate each and every faculty members of the ECE department in this regard. It's a group show. It's the team spirits. These are all visible. Once again, appreciating the head of the department who is driving force for the ECE department. Of course, with the blessings of the Venkatesh Prasad and Rohit and other new members joined to the department, I hope that they are also going to give the best to the department. Now, coming to the technical part. See, who said that things are very minimal to the individual? No way. The sky is the limit for any individual in getting the knowledge or acquiring the knowledge to the individual level. So there is no COVID, there is no commuting facility, there is no any hurdles to all of us. Once there is a power, once there is a knowledge, nothing will come in between. We will take the knowledge to any extent. That is how even during the pandemic situations, no one stopped, and the knowledge transferred, knowledge gain, everything happened to all the participants. And learning the new techniques and sending it to or transforming that in turn again to the needy people, that is to the end users, is very important. For that, every time you need to update yourself to the current day technologies. That is how, with that plan, we have started conducting this particular LabVIEW workshop to all you guys. Okay, so learning the new tools, new techniques for a professional approach, for professional growth in engineering college, that is through, in academics, is really important, and we need to stir that. That is very important. Every faculty and every participant should have that cult to improve their knowledge to the current day technologies. So I request all the participants, you must make it as in a habit, and you must go always to learn new things, new tools, which are more important to the upcoming students, technical students. Now, as you know, the two phases of the STTP on applications on NI Lab View were successfully completed by enhancing the great knowledge of the lab view to many faculty and student community. And after learning all these things, you don't stop at that point of, the same area. You have to diversify. You have to transform it to the next level. So train the trainer's concept to you have to bring that concept in you. That means once you learn something at one place in one seminar or in a workshop, immediately after going there to your places, you have to give the seminar and workshops again to the next level of people. That is the only way that we can progress in our knowledge, and we can diversify the concepts and the knowledge to the end user. So this technique must be implemented in your lifestyle. And as you know that LabVIEW is a great advantage that I will have, it's a compatibility over any engineering branch, and knowing the hardware components like my DAC and my Rio will help us or will help to the user to implement any kind of applications nearby in their area, in the environment, in their working areas. LabVIEW helps to the visualize every aspect of engineering application, including hardware, configuration, simulation, measurements, process control of the automation and debugging. These are the couple of areas that you can straight away, you can use that, you can implement and deploy the things at your end. So having this knowledge to you and carry that and start implementing in areas, and after doing and conducting the number of experiments, you have to convert those points, those experiences in terms of the publications, not just having the knowledge in you, and you have to put it in the practice, and you have to enhance that your metrics of your individual capabilities or skill set. That happens only when you are going to publish the papers through experimental work through this LabVIEW. So the bottom line is, whatever the knowledge that you gained from this, go for the implementation mode. Try to get the results, analyze the results, develop the data analytics, publish the papers in the good journals, Scopus or other that line, and gain and then increase your skill set and increase your resumes. So this type of the habits, this is one of the best practices that we have done right now. So keep appearing, keep attending to the number of conferences, seminars and workshops. It must be a continuous process for you. So don't miss the opportunities whenever you will get across. Try to get knowledge, because you are in academic side. You are the major pivot. You are going to play the pivotal role to the students in transferring the knowledge. Unless you have the knowledge, you cannot deliver the good goods to the end user, that is to the students. So keeping all this in your mind, and I wish you all the best. I hope that you had a good time in the workshop and carry the knowledge, and I wish you all the best and a happy Sri Ramanavami on behalf of the NCET. Take care and stay safe. It is your life. You keep wearing the mask and everything, okay? And all the best, and God bless you all. And with a great, sir, I am taking leave. Jayaraman Iyer, sir, you please take the things forward.
Thank you so much, sir.
Yeah.
Thank you, sir. Thank you,
Yeah.
sir, for your fine detailing about STTP and briefing about the importance of the STTP. Thank you again for your encouragement, knowledgeable and kind words. I would now request Dr. Nagesh Kane, Professor and HOD Department of ECE, NCET, as well as the convener and coordinator of this STTP, to address the gathering. Over to you, sir.
A very good morning to all of you. Respected Principal Dr. Jitendra Mungara, Dean R&D Dr. Kumar K, Keynote Speaker Professor Jairaman Sir, Dean Quality Assurance Dr. S. Mohan Kumar, HODs of various departments, my dear faculty members and participants of the STTP Phase 3. I am Dr. Nagesh Kain, Head of Electronics and Communication Department, feeling deeply honored to brief about the procedure and protocols followed in the conducting AICT sponsored 6 days short-term training program Phase 3. I was really amazed to see the impressive registrations. We had 150 registrations, but as per the AICT guidelines, keeping in technical constraints in mind, only 100 registrations has been shortlisted on first come first serve basis. We have eminent resource persons from reputed organizations and industry. I thank NCET management, principal sir, and EC department staff for their continuous support and efforts in executing this STTP in NCET. I wish all the participants all the best, and I am sure a lot of knowledge sharing and learning happens on this entire 6 days. Thank you, everyone. Thank you, Jairaman sir.
Thank you so much.
Thank you, sir, for briefing about the procedures and the protocols of the STTP and for always being a guiding light. Now, directly heading towards the end of the inaugural session, I consider it's my privilege and honor to introduce the keynote speaker for this session, Professor K. Jairaman, Competency Developer, Bangalore. Professor K. Jairaman has completed his graduation and post-graduation from BITS Pilani. Professor K. Jairaman has 10 years of research experience in the area of defense and space and 15 years of industrial experience where he's been a CEO, technology product and manpower development, marketing, customer support, brand creation and management. He has over 25 years of experience in academia as developing and nurturer technopreneur. He's been a success assurance partner for National Instruments Academic Relation. His expertise include transforming the engineering degree holders to engineers through the internship and mentoring, enhancing employability in core engineering industries, technopreneur development programs, short-term FDP and SDP. He has delivered various technology webinars for academic community during the pandemic, which topics include systematic approach to the solution engineering, electronic system level design procedures, enhancing employability in core engineering industry, Industry 4.0 automation engineering. With this introduction, I conclude the inaugural session. Thank you everyone for your patience and cooperation. Thank you all. Participants kindly note, session 1 is going to begin by Professor K. Jairaman for the day 1 on evolving technologies and an impact on teaching learning process. Over to you, sir.
Thank you so much. I need some help to get my slide on the line. Okay, though I have been doing this many times, but every time I falter. Okay.
Yes.
Good morning to you all first, and excellent introduction about me. Hardly, I don't know whether I will become able to come out to that level, but I will try my best to do it. Both today and tomorrow I will be doing it. So I am left with just 1 hour or so. Normally 1 hour is too less, but still I will continue this particular topic tomorrow also a little bit, and then proceed with the research areas in those areas. Okay, that's actually the plan. Please listen carefully, and if you have any question, do not hesitate to contact me on this particular webinar itself or through the email ID which I will be sharing in all my slides. Okay. And what is our interest is ultimate purpose is actually I am not a great knowledgeable fellow and all, but I have the ability to study and get back to you with a reply. So ask questions, as many as you like and whenever you like. Okay. And I will be too happy to answer. And the intention of the AICT sponsored program, as informed by the principal of this institution as well as the head of department and all of you, as you know, all of you. And what is interest is actually you have to learn. Okay, it will be difficult to sit through for a 1 hour or 1 hour lecture It's difficult. I know that actually, but please bear with me and try to do it actually. Okay, try to sit through. Okay, I'm going to do that actually, and is it coming online, gentlemen?
Yes, sir. Yes, sir, it's visible.
I should come. Not coming.
Yes, sir, presentation is visible.
It's not visible to me. That's a sad thing. Huh? It's not visible to me. What should I do? I don't know. I'll again get back. Is it okay?
Yes, sir. It is visible.
Everything is fine?
Yes, sir.
Okay, thank you so much, madam. And please be online so that whenever the slides are not visible or I am not audible, you do not hesitate to contact me. I'll be too happy to answer it. Okay. I have switched off, I have put my phone in a low tone so that I will not disturb the audience, and my phone will not disturb the audience. Okay. That's the basic idea. And I am working with a broadband, and as you know that we have a Smart India, Smart Bangalore scheme going on. Many times the cables are cut, and it can be a power cut or a wideband or broadband cut, and it will avoid, it will actually restrict our talking. Okay, but don't bother, we will continue with that. Okay, do engineering, evolving technologies and relevance of graphical system design, closed loop teaching learning process. A beautiful topic. I don't know how much justice I will do to this. Okay, this is actually what I have been trying to do to institution. I would have visited about more than 1,200 institutions all over the country, and also spread this particular message to everybody. That is, my interest is core engineering. I don't, though I can talk about software engineering process today, but I am not recommending people to go to IT, particularly from the Department of ECE or any other circuit branch, or what we call actually the mechanical engineering, etc. Though I do not recommend, but however the pay packet is so good that you cannot refuse, or your parents will not allow you to refuse. But it's okay. That's a different issue. Impact. Now I have brought one word called impact. This is my interest actually. That is, things are not the same way. See, once upon a time when I was doing my engineering in BITS Pilani, okay, BITS Pilani, I joined when it was a Birla Engineering College. I don't know what came to this Sri G.D. Birla ji. He converted that institute into Birla Institute of Technology and Science once it became a university. So he removed engineering, probably for the obvious reasons, because engineering is different, technology is different, science is different. Engineering teaching cannot be done by many people. So he thought, with the foresight that he had, so he said that actually let us concentrate on technology and science, leave the engineering to some institution, some other institution. Probably that was his thing. So impact and imperatives. That is, once we are going to talk about things have been changed. See, for instance, in 1965, I am from a small village in Tamil Nadu, and I have moved over to Pilani for studies, for whatever reason it was. Okay, electronics and telecommunication was my subject, and so 1962, somebody getting admission in electronics and telecommunication, there were only few institutions in the country offering that topic, and Birla Institute of Technology and Science, Birla Engineering College was one of them, and after 3 years it became Birla Institute of Technology and Science. Okay, that's what it is. So the basic thing is actually teaching is different. That is what you teach the same curriculum, you teach the same subject, but the way in which the student understands, or this way in which the faculty guides him to learn the artifacts of the engineering, technology and science has to be different. Everybody cannot become a scientist. Everybody cannot become a technologist. Everybody cannot become an engineer. Please understand. You can get a degree, BE or BTech or BSc, BCom, MSc, etc. But really speaking, what you are going to do is depend upon what you are capable of. Okay, something can be developed, many things cannot be developed in a human being. So impact, so evolving, things are changing, things are changing. Please understand, today you are going to talk about a software programming. Tomorrow you will have one tool. Once you give your inputs, actually, the program will be developed, debugged and ready to be installed. That's all it is. So the person need not know all those syntax, semantics, etc. As it is, if you really look at it, actually, when you move from basic language to C, C++, now I'm talking about LabVIEW as a language, you have abstracted yourself from the hardware relevance and moved over to something like abstraction is a very high level. That means you don't really know what is the hardware on which you are talking. So the syntax is not actually very, very important, syntax learning. Unfortunately, we teach the whole year on C, Java, C++, Python, etc., etc. It's not necessary. People should learn the language themselves. We should only talk about the what we call actually the programming language, how compiler design, those type of thing, but not really the language. That is the impact and imperative. One of the impact and imperative, foolish to talk one semester full of C language or D language. People have to learn in the lab. If it is required, actually, you have to talk about a pointer. You go to the lab and explain him, this is pointer and this is how it is built. That's all it is. This is what we are going to talk about. This is how we learned. Okay. So this is the system. Actually, if you really look at it in this particular schedule, what has been put in, though he has written very, Dr. Rohit has been very, has got a lot of forethought and told that it is only tentative, sir. But actually, I hope my program, my session 2 days is not tentative, is fixed, because third day I'm not there. Okay. So first 2 days, I'm the 9:30 to 11. We have already crossed 10. So that is actually the area I have reserved for myself. And I'm sure Rohit has been too kind enough to provide that particular slot because I enjoy that particular session. Okay. So there he has called many people, and there are lots of experts in the LabVIEW who are going to crowd you with LabVIEW and LabVIEW and LabVIEW. So my session will not have too much emphasis on the LabVIEW construct, because in front of the VA solution as a company and their executive, it will be too really, I will be too naive to talk about the LabVIEW because they know much more than what I can talk. So you learn. I only give you a glimpse of what can be done with the LabVIEW. That can be done. That's going to be told. Okay. So the first and the foremost, why this AICT is providing money, or STTP is conceptualized, MHRD is giving, all the universities are pouring money, etc. This is actually their vision. To develop and nurture a technical education system in the country which would produce competent manpower of the highest quality comparable to the best in the world and in adequate numbers. There was a time when I used to complain, why so many engineering colleges? If you really analyze, the engineering colleges are supposed to provide the best manpower available. I have used a word called competent. I am supposed to be representing a company called competency in ICET. That is competency in information, communication, electronic technologies. That's actually ICET expansion. Competency means knowledge plus skill. Down the line, I will explain what is the difference between knowledge and skill. That's actually the way. Okay. Provide the nation a competitive advantage in the creation and propagation of innovative technological solutions. That is, what it says is actually, see, there is a syllabus created, probably 3 years back or 2 years back. Last year, it has been revised. So, but technological advances is not going to wait for you to change the syllabus. It will keep on going. So, there should be some facility there so that the institution will be able to impart that advances in the technology or in engineering to the students so that they will be properly positioned in the industry on the day they graduate or they postgraduate or they get the doctorate. Okay. So for that, they are funding really. Okay. Develop technological capacity of the highest order for its application in economic development of the country. See, whenever you think of lots of people are pursuing medicine, okay, and nobody is going to pursue a discipline just because of the fun of it or for the sake of I love medicine and all. There's no, I can earn more money. Okay, I can earn more money. If somebody is coming to engineering, I can earn money. If it is going to law, he knows that he can earn more money in that. He can earn. Ultimate objective is how employable you are after securing that particular degree or diploma or post-graduation. That's all it is. Okay. So, if you really look at it, doctors, medicine. And what is the basic thing? If the healthcare is poor, if the people in the country are suffering with a lot of diseases, etc., like COVID or the time being, and if you need more medical practitioners, okay, practitioners. And if the whole country is full of crime and violence and looting and other things, etc., you need more lawyers. If people are interested in maintaining their accounts and probably window dress the accounts to suit the various people, partners, auditors, and probably to himself, all those things, then you need economists or what we call actually commerce or chartered accountants, etc., etc. Okay, company law board, you have ACS also available. So many things are available. But engineers, please understand, engineers are producing something. That means what? Today you take a doctor, you go and look at his dispensary. He has on his arm's reach, he has everything which are electronics. He doesn't understand one bit of electronics, but he knows how to use it. It's image processing, it is embedded system, it is bedside monitoring system. It's actually beautiful data acquisition system that are put there. So if you really look at it, actually, for the medical practitioner to become effective and efficient, you need to have a great engineer by side of you. That's actually how medical electronics, biomedical electronics, all these things are basically an offshoot of that. Major, that is, we want to, that is the country, as a country, what is our Prime Minister keeps on telling, Hamare Desh mein, lots of people are here, lots of young people are there. I have to provide employment. I should not look only into the country or the government job. I should send them everywhere. That is, whether they want to go to Japan or Korea or US or Britain or Germany or some other place, actually, I should be the best supplier of best manpower, particularly productive manpower throughout the world. This is actually the one. This is a charter. This is nothing. I have not created this. This is in the website of MHRD or in the AICT. Okay. Now, once the country gains competency-based competitive edge, it becomes ever easier for it to maintain its lead and even harder for its competitors to catch up. That's actually what we are doing. We are excellent in software management, IT management. You give any company to you, an Indian, and ask them, I want this company to be digitized. I want IT to be everywhere. Okay, so he will do it properly. Our TCS, our Cognizant, our Accenture, our HCL, and those type of companies, actually Infosys, those type of companies have really put that particular thing all over the world, thanks to people like Narayana Murthy or Ramadorai or somebody like that. Okay, they have done a wonderful job in spreading that our country is excellent in IT management, IT-enabled services, program development, and system development, etc., etc. Okay, this is what it is. So we are good. Okay, so why not we take that particular thing and then go further? Why not we create, using this particular software lead, create some hardware and try to build, say for instance, IoT-based solution. embedded system, medical gadgets, medical devices. So many things we can do, with that help of that IT excellence in us. Okay. You say actually many of your people will be employed in one of these companies like TCS, etc., etc. So those people are going to produce this. Okay. So that is actually the one. Okay. Now, I said that engineering and technology has a difference. I am sure Jyoti madam and many people who have attended keep on listening to this particular story. But I'll continue to tell the story because I really have to catch the last person in the bench. Okay, in the bench, to know about the difference between artist, scientist, engineer, and technologist. BE, BTech doesn't make you engineer or a technologist. Please understand, engineering degree, a small paper, according to me, it is really not worth it. Unless otherwise, in your thought, in your mind, you are not an engineer. You are an engineer. Unless otherwise you are an engineer, you cannot become an engineer. Okay, this is, or you cannot practice engineering. Okay, this is my view, and I am quite clear about it, and I am positively sure about this also. Okay, once you say this, what is the basic thing? Now I'll go straight away to the topic. Artist is one who has 360 degrees of freedom with absolute freedom, no nothing else, and should be very, very creative. Today, A.R. Rahman is great. He is great because he uses all type of languages and tries to do it. You must have all heard about why this Kolaveri D in all the things. It is a simple song, okay, and possibly rhythmic. And it has moved even people like Amitabh Bachchan, who is far away from this zone, okay. And what is the basic thing? It is actually innovative, and it doesn't have any constraint. So that is actually the one. 360 degrees of freedom with absolute creativity. Now go to scientist. You take actually Newton as a scientist. Okay. Newton as a scientist. Now, an apple fell down. And apple fell down. Newton starts thinking not about the apple and quenching his hunger. He thinks about what is known as actually, why this is falling down? Why not it go up? Okay. So that created a lot of thoughts, a lot of experiments, lot of this, etc. And that is what we ended up with, huge mathematics books on dynamics, statics, all those things. Actually, if Newton has not been there, we would have saved our headache of studying dynamics and statics. Thanks to Newton, we are suffering. Okay, thanks to Newton, we are suffering. And look at it actually. You start, look at the dynamics and statics book. I used to study from Loney, S.L. Loney, and you try to take one exercise and answer it. You are the best person in that particular topic. That is actually that very, very great principles are applied. Okay, that's actually the scientist. Scientist is one who gives a postulate for a phenomena or for an event which is already occurring. You take Raman spectroscopy, Earth is a sphere, all these things, scientist things actually, you will see that there is already an existence. He is giving only a theory or a postulate. Now come to the engineer. An engineer, if you really look at it, engineer and technology, according to you, there is no difference. According to me, there is 100% difference. Okay, 100% difference. An engineer is a creative person. First thing is a creative person. Okay, engineer is one who creates new things. Okay, and he has creativity but limited freedom. Unlike an artist, limited freedom. What does it mean? He has to ensure that the creativity is bound by the physical and mathematical principles and laws. That is why we end up teaching all the students with a lot of mathematics and a lot of principles. See, Ohm's law, it's a law. Kirchhoff's law, Thevenin's law, network theorems, all the theorems, etc. We teach not because we don't have any other thing to teach, but because that is the basic principle on which you should be able to become creative if you want to become an engineer. Okay. Now technologies. Now engineer has created something. Somebody has to take it to a marketable product. A technologist is one who starts from the creativity, who who takes from the creativity and then makes products, new way of thinking, new way of doing things. That is actually new markets even. That is actually technology. So now if you really look at it, engineer, creativity, no boundary, that is artist. Scientist, teach and learn physical laws. Principles, theory to the existing ones. Creativity, engineer, creativity is still there. Must obey science, it is still there. Mathematical and physical laws and rules, that is what it is. You take any creativity, if it doesn't obey mathematical, physical laws, it is not a creative, it is simply an artist. Okay. Technologist is application of that creativity to building new products, material, process, and etc. etc. Why, sir? Why are you telling all these things in a LabVIEW session, sir? Yes, all these things need experimentation. In experimentation, you cannot do a full-fledged experimentation without LabVIEW or without LabVIEW and any other products. Experimentation, what you are doing in the lab without LabVIEW or anything is you are doing exercise. You are not doing experimentation. Experimentation is the one which makes an engineer, scientist, or a technology. You take actually your own actors, whomever you like. Actually, I like Nagarjuna, so I will continue to say Nagarjuna. See, person, he must have dramatized himself in front of you. Sorry, I'm coughing actually mainly because I had a Covaxin vaccine shield day before yesterday, so I'm little feverish, but it's okay. Whenever I come to technical talking, these things will not bother. Slightly cough will be there. Please bear with me. Sorry for the trouble. Okay. The Nagarjuna, if you really look at it, he must have acted many times in front of the mirror and then try to come out with the best performance so that he is the best actor in the world. Okay. That is what in our days, N.T. Ramarao or Nageshwar Rao, those type of thing, or even you take Gantashala, what a great music he used to sing, you know. So it's a great thing. Rajkumar cannot act like this if he has not experimented with various things. That is what it is. Every discovery, whether it is an artist or scientist or engineer or technologist, you have to have a lot of experimentation. Experimentation in the conventional way, what you have been doing, what I have been doing in my years, you cannot do it now. Let us take one simple example. Why LabVIEW and experimentation now? Why? Now you take a thing. I am doing on simple amplifier. I'm sure you are all ECE students or ECE faculty. So simple thing amplifier. Okay. You have an oscilloscope, that is waveform monitoring, waveform display system. That is, I don't call that a CRO because now no more cathode ray is used. It's all LCD, LED panels. So we should call that as waveform display unit. Okay, waveform display unit. And waveform display unit, you take it actually today. And what is the least count in the vertical scale? Probably 5 millivolt per division, or actually 10 millivolt per division if you go for a cheaper oscilloscope. Okay, a cheaper waveform display unit. Now, assuming that one person wants to really become an engineer and he wants 1 millivolt resolution, you will be really 1 millivolt per division resolution is very expensive. You go and ask your principal or the management, I want one oscilloscope with 1 millivolt per division, but it costs little around 75,000. Ordinary oscilloscope costs only 15,000 or 20,000. This cost. Nobody will permit you because you will be doing it one day and afterwards it will be simply junk. Now, going from 10 millivolts per division to 1 millivolt division, in the conventional way of doing the experimentation, I need to change the waveform display unit. But with the software-defined instrumentation using LabVIEW, you just have to change the full-scale deflection. That's all. It is so beautiful, so easy, and scale change is not a big thing. So you really know experimentation becomes very easy and very, very convenient with software-based display unit or software-defined instrumentation system. Yeah. Now, I want to talk a little bit about the thing. You are all teaching to the students. Ultimately, I don't know whether the students are benefiting by your teaching because of the simple reason, if everybody ends up in TCS and Cognizant and other places, and you are teaching electronics communication with the Maxwell's 4 laws and with actually the VLSI design or Moore's law or anything like that, and he goes and does some Walmart management, actually, what is the benefit of his 4 years of engineering, and you are teaching on that person? So the more people going to a IT industry from your institution, from your department, talks very bad about the faculty in your department. Very talks. Because at least 10% of your student should go to core engineering job. What have you done to that? That's actually, last year one fellow went, okay, no problem. Can we make 10 people this year? Can we make 20 people next year? This is how it should be. There's no point in increasing the strength from 90 to 180 to 270 students per batch. No, 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 no. How many of them are really pursuing what we call actually electronics and communication, engineering based job? Even if he finds out a good embedded system, a medical device, medical equipment is good. This is what is going to be talked about in this. Personal positioning for engineers and technologies. Now, I will be using actually engineering and technology very, very casually, and please understand, you know the definition very well, and you have to continue with that. Okay, with more people competing for every year, the electronics and communication students from each of the institution is 180 people minimum, 270 people some of the institution. There are about, assume that there are about 5,000 institutions. 5,000 into 200, you count it because I am too old to count and all those things. And every year those people have to be there, and your industry is not in a position to employ all of them, So what is the basic thing? There is a stagnation of job, and there are lots of people who are jobless. Okay. Now, I want you to provide your student the following A's. See, in a 3-card game, 3 A's are success. Okay. Now, in a 4-card game of employability, 4 A's are success. Okay. Appropriate. The technology, what you should know is appropriate. The idea, what is using, should be appropriate for the problem he is having, and it should be authentic. That means it should not be copied. Google survey, Google search is not a good thing. Attractive, it should be attractive to the user, to the owner, to the buyer, and it should be affordable by the buyer. Okay. See, for instance, I can make one washing machine costing 1 lakh with excellent facility. It's not affordable. How many people will buy? Not possible. So it's actually, you should try to look at it. That means what? Whenever you give, I don't know whether you are giving that actually, we are doing that. Suppose you in your exam, in your lab session, I don't want to say exercise or experimentation, you say you want them to make an amplifier. That fellow should go through the complete amplifier structure, not take one old circuit and try to build it. Okay, he should try to see, and he should find out that his design is appropriate, authentic, attractive, and affordable. Okay, and that amplifier is not worth, even if it doesn't meet one of them. In the industry, what I used to manage actually, because I was the chief executive of that, if every solution should have a problem definition, and you have exercises or lab things where requirement is never given to the students. He is just coming and taking the old circuit and try to build it and show the readings, show the outputs, and simply walks off. 3-hour session, he does it in 45 minutes or 1 hour, not acceptable. He doesn't understand. 2 or 3 hours, he is wasting his time without understanding anything. This is what is the thing. Okay. Now, what is the basic thing what people ask? You have got a degree, sir. Okay. What do you know? This is the question which we ask. Okay. If the student says, I have a I know power supply. Okay. Assume that our student asks, I know power supply. Then we ask them, okay, which part of power supply? No, sir, the whole power supply I know. Oh, beautiful. Switch mode or regular, DC, linear? Linear only, sir. Okay. Linear, what is the disadvantage? Okay. This is the first question we normally ask. We don't even ask him circuit diagram and all because he knows, okay, what is the disadvantage. He says something, okay. And then we ask him actually, if there is a rectifier, in that rectifier I have a diode, and whether it is a bridge diode, bridge or full wave rectifier, don't bother. I want to change the diode, okay. What are all the various specifications that you will look into the diode to change that particular thing? Today you don't have to know anything about the power supply because power supply is a bought out item in many of the equipment, okay. So at least your student should be able to measure the performance. He should know what is cross regulation. He should know what is regulation first, line and load regulation. He should know what is the ripple factor. He should know how to measure the ripple with a small waveform display unit, okay. All these things he should know. Because of the simple reason, we ask what he knows. Because we don't bother about what he doesn't know. There are millions of things I don't know, and I'm sure many people don't know. We are not bothered. We want to know what he knows. If he says, I know how to do soldering, the first thing which he'll, so I know soldering, sir, I will solder anything, sir. Okay. First thing I will ask him is, what temperature the solder melts? That's the question we ask. If he doesn't know the answer, what soldering he knows? This is a problem which we face with the students coming, particularly freshers, because they are not educated. They are only asked to mud up certain sessions, and then he goes and vomits in the thing. Unfortunately, with the COVID, only one positive thing for the students is actually we have COVID pass people. That means he doesn't have to enter, he doesn't have to appear for the final exam at all. He will be passing. So what he will know? He is not being tested. Will you get into a scooter? Why scooter? Even a small bicycle, if it is not tested and proven worthy, you will not. Then how can we take the engineer who was not tested? We will not be able to take him. So look at the problem. COVID is very beautiful because we can talk over this particular web, and I don't know you and you don't know me, and we can talk and move away, and our session is over. We get a certificate at the end of the 6 days, and that is all it is. That's not correct. The COVID pass people will never get a job in good companies because they don't know anything and they are not tested for knowing anything. It's very difficult. Employer seek skills found outside the classroom. It's very difficult. Okay. So we don't bother about whether he scored 80 in the electronic circuit one, etc. We just ask him, what are all the 4 important specifications of an op-amp when you are using it for an audio amplifier? That's all the question. Okay. He should have known because he has got 80% in the linear circuit paper 1, paper 2, whatever it is. Okay. So if he doesn't know, what is the use of that knowledge? What is the use of that marks? It's no use. There's no use. Very difficult. Okay. Now we talk about this century. When what one does today may not do what it is. Okay. See, we don't know what we are going to do tomorrow. Actually, you will be really surprised. I used to design on computer for sound ranging as soon as I got into a job in defense. When I went to ISRO, I was asked to design the circuits for a radar or tone ranging system or interferometry system. That is different and this is different. So the basic idea is your core engineering remains the same, but the way in which you are applying will differ from a radar to a simple computer for sound ranging. Okay, computer for sound ranging I designed in LRD in 1969 sometime. So today I go and see in the Bharat Electronics, it's a small piece where I used to make it as good as a Godrej cupboard. But now it is a small piece which can be carried in your pocket. That's that level. So that is actually what is growing. Globalization, outsourcing, mergers, acquisition will impact how one is expected. If you are working in a Google today and you are employed in, say, for instance, Microsoft tomorrow, the methods are different. You have to adopt. You have to really accept that. One will determine success by his ability to position himself to take advantage of the opportunity and respond to change. I can provide a job, but growing in the job is not my capability. Growing in the job is his capability. So his capability. Otherwise, I'll mercilessly throw him out after 6 months of trial. That's all. Okay. Marks don't count. Marks counts to a small extent. Knowledge, competency counts more. One will look at several employment and career options to help to determine which one will work for him. This is what our people are missing. Okay, not all of the options will work for all persons. Okay, and the key to succeeding is to understand oneself, how one responds to change, and what level of risk one can deal with. One will also look at such career options, etc., etc. Okay. So engineering education today, this is all not written by me. Please don't ever think that Jayaraman has written all anti-engineering colleges. No. This is written by, I think there is one Indian Engineering Council, and they have written this, okay, based on their own assessment. See, there are some people from TCS or anything who goes to some selected colleges only, not other colleges. There may be other reasons for that, but the one reason is actually the college input is good, the college studying mechanism is good, the examination is properly conducted, and the assessment is properly done, and though they go to that college. Please understand, they go to that college only because of that. Bachelor's education itself has become specialized. There is no curriculum change, is not possible. Please understand, curriculum change probably can be one optional papers or elective can be given. Curriculum has to be so very strict, and the person has to learn beyond that. That is why we all look for learning beyond syllabus. Okay, emphasis on developing the engineering student as a researcher than the practitioner. Researcher, what is the difference between a practitioner and a researcher? Researcher discovers what is not in front. A practitioner uses and exploits that capability what is in front of him. That's all it is. Okay, researcher will discover or research or will carry out too many studies on something and create something that was not in front of him. Okay, catering to the companies and industries that give money to the school. So suppose I have a chair from Nokia, I probably have to teach more Nokia. If I am getting some money from, say for instance, LabVIEW, NI, you have to teach LabVIEW, not MATLAB. I'm telling you, this is a problem. Okay, the colleges are looking for money and the industries are giving to promote their products. Educating is a secondary or tertiary thing only. Please understand. We don't do that. I know about the institution. We fund if you put it in the syllabus. Okay. Strong emphasis on the academic aspect in the college experience. That is actually, we are more bothered about the academic. You take any of the faculty, even today your people were talking about, you are only bothered about how to publish more papers, how to really do it. In the undergraduate education, you have to know how to teach the fundamentals properly so that the students understand the fundamentals and grow on that thing. So fundamentals are given a very casual thing in our country nowadays. Okay. So if I ask the fellow, what is the difference between linear and non-linear? There's no, they won't be able to answer it. Okay. So that is actually the problem about it. Very small percentage of activity industrial. So we say there are some institutions, particularly in Coimbatore I have visited, they all go in summer for a industry internship. I had done this industry internship for the faculty for about, I think 5 years. 5 years. The first year it was 25, second year it was 18, third year it was 12, fourth year it was 4, fifth year it was only 1. The faculty, it's not actually my disqualification. The faculty doesn't feel the industry work experience is required because they don't teach subject from an angle of employability. They teach a subject from the angle of completing the syllabus, and syllabus itself is very hard. Okay. What do engineers do in India? You can find engineers at all levels and in many industries. Engineers design buildings, machines, and factories. Engineers teach, perform research, and invent. Engineers manage companies and work for charities. Engineers impact the world. I have seen one fellow who is an IIT graduate, I think. IIT graduate who is a great computer science person. Really speaking, he was a student of Kamakoti, I think. Okay, Professor Kamakoti. What he has done is actually, He is doing what is known as actually waste management. There is one person who studied with me, IC engine, excellent person. He did his graduation in PhD, best institute, mechanical. So he did his post-graduation in IC engine. Now what is he doing? He is doing what is known as waste paper recycling. Okay, recycling. Okay, and there's no relation between IC engine and waste paper recycling. It is engineering. Okay, that's all. Take and pass ENT, engineers and technology examination. Work for 4 years under the supervisor of a project engineer. Take and pass PE exam, also engineer. Not consistent between state. Not all engineers take the exam in their field. Most take exam only early in a career. Longer the gap, tougher to pass. Based on theory, not practice. This is my situation. I wanted to do PhD, not because I was very great research fellow. Every college was saying that if you have a PhD, we give you 10,000 rupees more or some good position. And I was searching topics and of course guide. And I was not able to find a good guide who is willing to spend time with me. And I couldn't find actually. And I kept on waiting. My daughters have become very, they have become mature. They have become 20, 23. Then I got into the marriage thing. Then some professor told, why you doctorate here? You don't need doctorate. And all those, my experiences only is going to be presented tomorrow as research topic. I would have seen about 1,000 research topics in diversified areas, pursuing, including software engineering process for embedded solutions. Okay, I did all those things, and I had a guide for all those things, but somehow I couldn't proceed because he was not pushing me, or I was not pushing myself. It's a very difficult one. Okay. Changes in engineers are expected to be able to do anything assigned to them. This is, look at it, I said. Anything assigned to them. That is, I will say, you are teaching, say for instance, 8085 microprocessor or 8086 microprocessor. Nobody in the world uses 8085, 8086 or anything. They are not even using ARM processor, they are using a variant of ARM from Intel or from many places. So what is the basic thing? If you come to if one student of yours comes to my thing, I will give him one Infineon chip, and he is expected to learn the Infineon chip in 3 days, that is 72 hours only is given, and start building the system. If he cannot do it, he's thrown out. That's all. We don't wait for that. Okay, we're thrown out. So that is actually what is it. Unless he has a total grasp of computer architecture and organization, and learned actually few chips using that particular knowledge, he can really migrate to any chip. He can update. He can go to any chip that he sees in the world. See, for instance, what are you teaching? You are teaching ARM processor. Why are you teaching ARM processor? You are teaching 8031. Why are you teaching 8031? Give a computer architecture and organization course. Ask them to practice various processors on any problem or actually the experiment using any of the architecture that is happy, and justify why that architecture is most suited or most not suited. That's all. You learn the whole thing. You spend one semester in teaching 8051, one semester teaching what we call actually the ARM processor, and then you call that as an embedded solution, and there is no embedded solution in the topic at all. Very, very sad. Not good. Either through first knowledge or by using. Please don't think that I am criticizing the faculty or anything. I am one of the faculty. I also go through the same process. I teach the 8085 processor in the start actually. And then I went into the Douglas V. Hall book actually, and then try to teach interfacing techniques in, I think, Vellore Institute of Technology. Only interfacing. You bring me any processor, how to interface with, say for instance, keyboard or display, I will teach them. And that is what I was teaching, and I gained something. That means processor can be replaced, but interfacing knowledge cannot be replaced. That's actually the beauty. Need to gain more experience, how things work are built. Writing skills, we really lack actually writing. Whenever I ask some people, give me a report, that fellow gives a sketchy report, which is no use. Computer skills always increasing. Okay. Engineer has to hit the ground running that much faster as a result of it. We have certain generalists also in that 7 trends. This is actually what evolution of the technologies. Shift in global buying power, whether they are buying commodities or actually the employees, they have changed. Supply chain risk management. Suppose I have taken a project with people who are not suited for implementing that project, that is a risk. So I should be able to know the plug and play manufacturing plant. We're going to see in the electric vehicle what I'm going to show, plug and play electrical, hybrid electrical vehicle, okay, PHEV as they call. Depreciation of legacy hardware and software system. Tightening compliance. Today we are talking about Bharat 1, Bharat 2, Bharat 3, Bharat 4, Bharat 5, Bharat 6. Like that, it will keep on, regulation will keep on tightening, okay? And you should know what to touch. New channels for customer communication. Today, if you really look at it, actually, you will have actually the latency in 5G much lower than in 4G or 3G or 2G. Why it is lower? And what is the cause for that latency increasing? And how do we reduce in ease of the thing? The person should know the complete network. Then only he can really find out the source of the latency creation and try to remove it. New channels for customer communication. Today you have customer you take Airtel has failed, then you have to talk somebody, and that fellow will talk to somebody, and that fellow will talk to somebody. Finally, one person will say who is technical. Okay, Internet of Things, mixed big data. Internet of Things is in any conference. If there is no topic on Internet of Things, that conference is supposed to be not current. That is why I think Dr. Rohit and group has put the Internet of Things as one of the things. That's why I am also supposed to talk about Internet of Things. If I don't talk Internet of Things tomorrow, that means I am useless. That's all it is. Transforming technology. Look at, these are all taken from many sources. I'm not, please understand, I create my own slides. I may take diagrams from or figures from many places, but the slides are created by me and I take from many places. I don't know. End-to-end demands. This is actually transforming. Real-time supply chain management. This is actually just in demand type of thing. Okay, cloud-based. Everything is cloud-based. In-house and outsourced manufacturing. Everything is not made in-house. Many things are bought out. That means what? Your engineer must know the specification of the bought out item, must know how to test it. If you have to test it, come to LabVIEW. We will show you how to test it. In semiconductor industry, without LabVIEW, no semiconductor gets passed. In automation industry, nothing is without LabVIEW. If you really look at actually the automobile, LabVIEW. Actually, you will really see LabVIEW. It is a measurement and automation system anywhere in the world, in any technology that you can think of. That means what? If you understand, now I am talking about competency. If you understand what is the knowledge required and what tools are used, that means you are competent. That means what? If you know, say for instance, simple amplifier. There are 22 amplifiers which are currently used in industry. And those 22 amplifiers you know very well. Okay. And you know what is nobody is going to give you the job of, give your student the job of making an amplifier because they will buy it. Because your student cannot meet that. Okay. Particularly the time to market is a big essential now. Okay. So they will not be able to do it. That means what? Your student must be able to know the specification of audio amplifier. The specifications are different from instrumentation amplifier. Instrumentation amplifier specifications are different from cathode amplifier, high voltage rail power supply, and it's also different from what is known as actually sensor amplifiers. Okay, so all this you take actually you take a simple receiver chain. There is an RF amplifier, there is an IF amplifier, there is an audio amplifier, there is a video amplifier. All these four are amplifiers, but the specifications are not the same. The student must know the specification, must know how to create a setup to test it, and also to prove that this is the product we should have it in our receiver chain. That's actually what is required. That is, we are more interested in good compliance and rights management. Multi-channel customer service and support to provide. Machine-to-machine communication. What is that? It's basically IoT and in-memory business intelligence and robotics. This is actually. In the meantime, I'll go back to my I'll just open my. I have to open my mic for some time. Sorry, loudspeaker. Can you help me how to switch on my camera? Hello.
Sir, the camera symbol will be there, that you need to enable.
I'm not seeing a camera sign anywhere.
Sir, next to the microphone, you can just see it's a red color it will be in.
Where is the microphone? By then I should ask you that question.
It's at the bottom of your presentation. It will be there. I mean,
actually, there is one icon which is coming as stop sharing. If I press it, it will get.
That is for sharing your presentation. For the camera, there is a camera image. You can just see, sir, there at the bottom. You can you see meeting details, microphone, then the phone symbol next to that camera symbol is there. Down.
Yeah, I found that.
That you need to enable the.
Okay. Now,
we are able to see you, sir, now.
Is it visible?
Yes, sir.
Am I visible now?
Yes, sir.
Okay. Now, why I wanted to ask you is actually, I have gone through almost for about 45 minutes. Is there any question you have? Then I can ask you. That means what? Till now, I have only covered what is the requisite, how the industry is looking today of the students coming out of your institution or any institution, how one has to be equipped or one has to guide the students to get a job decent job for his survival or growth, whatever name you want to give it. And this is what it is. Anybody who has got a question can ask me now, or I can really go again to the slide and then start. Any question? Okay, if there is no question, I'm very happy because I consider that I have presented it very well, and I'll go back to my slide. Okay. Is the slide visible, Jyoti madam?
Yes, sir. It's visible.
Okay. Now, we talk about, sorry. All again, that's what some people will be shouting, but I will not do it. What we are looking at it actually, this is National Academy of Engineering. We are looking for what is known as actually sustainability, health, security, and joy of living. These are all the 4 criteria they have taken. And sustainability, whether whatever we are doing is sustainable. See, what we are supposed to, the industry is not looking at actually developing one today and forget about tomorrow. No. We should be in a position to use it actually. So what is our saying is actually, NI customers address these challenges worldwide every day, from developing novel and more economical source to the novel and more economical solar system. Today, if you really take, Ladakh has got one of the largest solar power generation equipment, okay, set up by our government of India, okay. And if you really look at it, actually, the solar panels have been really brought after gone through the complete test, including high temperature, low temperature test, and that is not possible. And the time to market is essential. If you have to do a time to market essential, then it is better you have a test equipment which will churn out the result faster. And if you are going to learn too many things to test a particular product, you are not going to end up anywhere. You are going to be in trouble. Okay. So next one is health. I'm sure all of you must have gone through this COVID business, etc. Anyone who goes to the doctor, takes a medication, benefits from the work of engineers. That's what I was talking about. The unique combination of basic biomedical science paired with engineering and physical science is necessary to create powerful tools and techniques that address pressing medical problems. NA customers expand. Actually, the medical is one of the things where every measurement is critical, and so it should be repeatable in every equipment. So you take a simple pulse oximeter, which everybody puts it on your one finger and see it. The technology of the semiconductor is so beautiful. It's compressed in some way, and there's a beautiful infrared ray which is going, and your pulse is actually stopping it. And using that, somebody is counting. All these things are actually put in that small piece, and look at the growth of the what we call miniaturization in electronic industry, and also the technology. So yes, earlier actually the pulse oximeter used to be a desktop equipment. Now it is finger top. One finger, you just put it actually, one finger will measure something else, and one thermometer will be inside your stomach, inside your mouth, and all these measurements are taken through, and the doctor is ready for working on your data. So that is the beauty of this particular thing, measurement. I tell you, healthcare is one of the various places where the testing is immense, because I cannot risk the life of people. So the testing has to be very, very pakka, and it should be fast turnaround. And next one is actually security. Out of 100 topics that you search in IoT, 95 topics are security. In wireless communication itself, security is a major thing. And if this IoT or IIoT, that is Industrial Internet of Intelligent Thing, the wireless communication is KOI. Lot of wireless communication, and that too in a small area. And if it is not secured, you don't know what will happen to your measurements and controls. Okay. So this is actually here also, NI provides a lot of help. And this is joy of living. Your product, you take your own scooter. Actually, if somebody has seen some of the election stunt in recent Tamil Nadu election, there used to be, most of you must be knowing, there is an actor called Vijay. He didn't come in a scooter or car or anything. He came in a bicycle. That bicycle cost heavy, and the helmet that he was wearing was also very heavy. That means what? It's a joy of living, I say. What's the big idea in getting yourself crouched in that small car or big car in a small seat? You enjoy the free ride. That is actually the way. So look at it. Here also we have given a look at the cycle only, and look at the cycle. A lot of testing is being done. NA platform are a critical part in the test process for many of the products we frequently use in enhancing our lives. Look at it, I say. Additionally, NA platforms. Blu-ray disc players. We have a lot of measurements to be done, and the NI lab should be used. That means what? If you have Signals and System Laboratory, DSP Laboratory, Embedded System Laboratory, Wireless Communication Laboratory, and you have Devices Laboratory, you have actually Electronic Circuit 1 and 2 Laboratory, and all those things. You have to convert all those laboratories. Only NI-based measurement system will be used. Since you are your Kumar has done a lot of job for that particular NI, and you change it actually. That means what? You don't need all those ready oscilloscopes and multimeter and all. Yeah, you can just put one small lab view on your thing, and you can measure anything you want, everything you want. The same laptop, he can use it in Signals and System Laboratory, he can use it in circuits laboratory, you can use it in embedded system laboratory, you can use it in communication laboratory. Why not? And what is the chair? What is the lab? So everything is beautifully owned by the student. So he can take the measurements and do in his room whatever they study. But see, all the students are not lazy. Please understand. Yeah, few persons are lazy. And I was also a student. I would have been lazy for some time. That's a different issue. You are also a student. You know what it is. And writing the lab report is one of the worst things that can. But today the students are happy in typing and on a laptop, So he will type the whole report, make the measurements, make the graphs, and put it all in a cover and send it by a simple email to your address. You check it and give him a correction, send it back to him. He corrects it and send it back to you. You evaluate and put it in your examination folder, and that's it. So you don't have to waste with a lot of, you don't have to cut trees at all. You don't need all those blue book, white book, red book. Anyhow, everybody is copying. So if you do this particular method of emailing the report, probably, I'm telling you, probably the copying will come down, student will improve. Okay. I have 2 more slides. I will take it, and afterwards I will do the presentation tomorrow also. Intelligent electromechanical system. This is the start of this particular evolving technologies. Program devices will progressively phase out many purpose. Actually, electromechanical. See, electromechanical system. You take a car, or you take a tractor, or you take a thing. It will become intelligent only when you put some sort of an intelligent device there. It can be a microprocessor, it can be a FPGA based, or it can be a simple circuit technique. But only thing usually decisions are taken by an electronic device with software or without software. Okay, that is actually, we call that intelligent electromechanical system. Okay, look at this. The realignment will be triumvirate between hardware, software, and mechanical engineers and technology. Why mechanical engineering is still in demand is because it's always ever demand. You go and see your antenna, I say, what is electronics in that? It is a small pole with a steel rod. It's a simple thing. The theory behind is electromagnetic theory and all. But the manufacturing is not anything electronics. It's mechanical. Okay. So without mechanical engineers, though, no engineering development will happen. Okay. This is actually what you should know. And with that, I close today's lecture. You have, this is actually your electromechanical system. It can be mechanical, it can be fluidic, it can be thermal, it can be chemical, it can be electrical. So I need actually some sort of an instrumentation to know what is known as actually the process variable from this plant. Okay. Now I have the computation software which is there. That is our electronics or embedded system or IoT based intelligent things, etc. This is what it is. Now this takes a decision based on other communication or the operator, and then take the actuation signal and give it to this particular thing. That's all. Okay. Your toaster, your mechanical system, or your elevator, etc., is only this. So what I am trying to do, what I was trying to do is actually now I come to the end of that particular my today's session. It is 11 o'clock. I would like to close it because I am feeling more feverish actually. Sorry for the inconvenience. I will continue the remaining topic because I feel it is useful to all the faculty. Maybe some faculty may not be interested in all the things, but positively, majority of the faculty will be interested because I am going to show the technological outburst as it happens in the recent future, and you will really see that it is required. I'm going to talk about electric vehicle. I'm going to talk about healthcare industry. I'm going to talk about IoT in all these applications, automation, and everything I'm going to talk. Of course, there is a small talk on the LabVIEW. Thank you so much for that particular patient listening. And really speaking, actually, I'm happy that I'm delivering this particular lecture. With all the difficulties that I am facing, I'm still interested because there's a lot of enthusiasm in this group of people who are assembled today for this particular lecture. And if you have any question, I am free for next 15 minutes or so. You can ask me any question you like. Please understand, I am free to answer any question because of the simple reason I am interested in the topic. I am interested in the welfare of the student. I am interested in the growth of the country. Okay, so if I am 75, all right, but I am interested in still. And tomorrow at same 9:30, tomorrow I'll get another half an hour more. All of you be present at 9:30. Whatever happens, because inauguration thing is not there. So 9:30 I will start. 9:30 to 11 will be the session tomorrow. And I thank the NEC, Nagarjuna Engineering College faculty, management, and also the principal and others for their agreeing to my talk today in this morning session. Thank you so much. Any questions? Rohit sir, can you coordinate, or Jyoti, you can coordinate and tell me some questions if there is any. If you have no question, then I will have some question, you know. So it's better to ask question than to answer questions. I was about to talk to this HOD physics, somehow or other he moved away from the meeting. One question you ask, I say, what is the problem? You are a faculty. No, you should know how to ask questions. We may not answer many questions, but asking question is not a big issue, you know. Okay, if there is no question, I don't want to trouble you more. Maybe you are waiting for your breakfast or coffee or something actually to munch. Please go, and look forward to see you again at 9:30 tomorrow morning. It will be more interesting because all those sermons have all gone. Now it's all engineering and technology only, and the lab view in it. Okay, and also some research topics I'm going to talk about. It's not research topic, it's actually reinvention or recreation of some other things that is happening. Okay, see, I'm not going to say that actually wireless is gone. You can create some more wireless. Okay, thank you so much. Have a good afternoon. God bless you all. Thank you. Hare Rama, Rama Rama, Hare Hare, Hare Krishna, Krishna Krishna, Hare Hare. Rama Navami, best wishes. Thank you. Yeah.